All right. Good morning once again to everyone, and welcome to our third class. So today we'll be finishing off with variables and how to manipulate variables and look at some key elements and methods in some variables. Following the last class, we touched a bit on lists. We saw how to pick out a specific element of a list to check out the length of a list, and we saw some errors, some common errors that can happen if you're not conscious about the length of your list. Today we're going to be talking about map. Now, a map is a data type that uses a key value system to structure its data. Now, similarities between a list and a map is that both of them contains multiple elements or can contain multiple elements. Yeah, that's a better phrasing, because sometimes either your list or your map can be empty, but they have the potential to hold multiple elements. That's one similarity. And second similarity is that both your list and your map can hold multiple data types if, keyword is if, you do not specify the data type. Example we have over here is list here, type list of my list. It contains integer, string, a map, and a boolean. Now we did not specify the data type that our list belongs to. And how do you do that? You first of all declare your data type list, then you put your greater and equal to sign here. Then you put in the data type that you want your list to be exclusively of. Now let's do list string. Now in this case, if we are to put 1 in here, it's going to flag it because 1 is not a string. If we put true here, which is a boolean, it's going to flag it because true is a boolean and not a string. So whichever data type you put, except the one that you defined it to be, it's not going to accept. So over here, we can now put string, I am, another string here, boys are worse than girls. It allows it. Same, same logic applies to your map. But now, a difference between your list and your map is that in order, okay, the difference is that the elements inside a list uses index or uses positions to get their value. Meanwhile, in a map, it uses the key to get the value of an element. Now we're going to watch this unfold. And of course, your map too, you can also determine the data structure. Now look at this, my map over here. You can see this first part is always your key. After the column, then this second part is your value. And of course, you have your separator, which is a comma. Now let's see how we can add data type to our map. Now for your map, it's a bit different when you want your map to be strict for the certain data type that you want it to be. Of course, you follow the same pattern here, but in this case, it becomes string, comma, then let's say integer, then map, let's call this one map int. Now, the reason why this is like this is because this data type here represents the data type of your key. Meanwhile, this second data type refers to the data type of your value. Now let's see if we can put int int. You can see int int. So in this situation, you can do something like 1, 3. That's my key value. You can do 2, 5. This is my second key value. But if I change here to string, it's going to flag my key section, that my key section is wrong. Now if I change here to string, or let's say boolean, it's going to flag my value section. So in order to make this compliant, then you go like this, gender true, let's say age, let's say false. Now, if you do not declare the data type of either your list or your map, you can put in any data type that you want to. Just like the one above here, where we have name, which is a string, our value, which is a string, name, age, which is a string, key name, which is a string, but the value here is an integer. Latitude is a string, over here is a double. Now let me put here bool. You see, it allows because we did not declare the exact data type we want our map to be. Questions? Questions? Oh, okay. No questions there. Now, the thing is, how do we now get a value from a map? Now, there is just one way that you can get a value from the map, and that way is by knowing the key of that value. Remember, for a list, in order for you to get the element or a value in a list, you need to know the position. For a map, you need to know the key. So let's go for print. Let's do my map. First of all, let's print it out so that we will see. I'm going to delete all this so that you can see my map here that we're referencing. So you see if I run it now, this is my map over here. Now, if I want to get only the value of latitude of a key called latitude, this is how I do it. Print my map is square bracket, open and close, then I put in the key over here. And once I run it, you can see it returned only the value, which is this over here. Now, you need to be very careful about the key spelling, because if you mistakenly miss a letter or anything and you try to run it, it's going to return null for you, meaning it could not find the value attached to that key. Now let's take a look at some of the methods of a map. Let's go dots and let's hit, and we know our customary is empty, is not empty, which also list has. Now let's look at entries, the map entries of this map. Let's hit it and let's see what will happen. Let me comment these two out. It returns map entry, map entry. Let's see if we can do any other thing here. Okay, yeah, of course we can go for that, but that's not what we are here for. Like I said, I will show you. You know, you will walk through it yourself. Now, this particular method is important because it returns all the keys of that map. Now let's run it and you can see these are the keys: name, age, latitude. Now once you have this information, you can now do some, depending on your use case, you can now do some manipulations to know if a key is available in a map or not. Now we can go like this and do dot contains and check if lat is part of the keys available in a map. And once we run that, you can see false over here. Now, David, you've seen that we've combined two knowledge that we have. One to fetch the keys and this contains method, which we used in our last class. So programming is basically combination of the little things that you learn here and there for you to solve a problem. Now let's look at first. Okay, it doesn't have first because it doesn't use positions. Let's take a look at others. Now you can see we already have a method here that says contains key, which is basically a combination of what we just did, which is this keys and dot contains. You can see this whole thing here, they shortened it to just contains key. Now inside this contains key, it does this operation and this operation together to give you the result. Now, if we run it, we'll get false two times. False, false. Now let's take a look at another one. Of course, you can.
Contains and contains key work the same way.
It's not contains and contains keys work the same. Look at it. Look at. Are you seeing the difference between the two?
Yeah.
And what is the difference between the two?
Keys dot contains then dot contains key.
I'm asking what's the difference now? You're just calling everything out. What is the difference?
One is saying keys dot contains, while the other one is saying contains key.
And do you know how we arrived at the keys dot contains?
No.
Lola, do you know how we arrived at the keys dot contain?
Okay, so you said you wanted to like map box with keys. And so you wanted to get the particular variables the keys contain.
Can you take that again?
You said that a map works with keys and list works with positions. So
Mm-hmm.
for this quiz.contain, you wanted, I guess you wanted to get the particular keys the map contains.
No. Using the dot keys, I said, look at what dot keys does. It returns the keys of this particular map. Then I went a step further to use this dot contains method to check if a particular keyword is a key inside here. That is how we arrived at this point. And that was why I'm saying this is a long method of doing it. There's a short form which is just contains key. So these two are basically the same. But this second step shows you the steps taken to get it. And of course, we can always expand this because there are multiple ways for you to achieve the same thing in programming. Now, I'm going to scroll down and see. And of course, we have our content value. We have the remove updates. Yeah. And let's see what update does. It takes a key, takes a function. Let's see. Okay, key. Let's see the example over here. No dot updates to value. Okay. Oh, it updates the value. So let's take the key of, let's say, name, and pass in a function, and the function must return a value. Let's call that value David. And now let's print out our map. So let's leave it like this and see what will happen. First of all, so I hit the run. It returned only David. Now, if I'm to print my map over here, you can see that now it updated this particular key to be David. This particular value of key name to be David. So let me print before and after so that you can see what that function did. For now, take a look at it. Name, James, and all this. Now, after we run this particular method over here, we're able to change a value using the key to whatever we wanted. Now, this is one way of doing it. There is another way of doing it, which is my map. You specify the key here. Let's still give it, let's give it age this time. And you just do equal to 60. And let's hit run now. You can see it over here. Can you guys see it? And are you guys following what I am doing?
Yes, we can see.
The second part of the question, Uncle.
We are following.
David,
Yes, sir, I'm hearing you.
Mhm.
You're
So you're
hearing.
looking at that print before the because to dollar sign in your map.
What's the problem, Lola?
You're looking at the initial print before and because to dollar sign, yes.
Why are you lost? What's making you lost or what's confusing you?
And the before, print before, I don't know, so
I
I don't
am
know the command you are about to give using the before.
I am just showing you the initial state of the data now. This is the original
Okay,
data
okay.
here. Then
Before
I did
just
some
and
code
the
here.
okay
Then I did after to show the effect of what this one did.
of the day. Okay, sir.
This is one way of updating a value in a map. This is another way of updating a value in a map. Now, let's see what happens if I put in a wrong key. It's going to throw up an error. Okay, yeah. Of course, it did not modify it because AG is not the same thing as AGE. So yeah, those are the two ways in which you can update your value in a map. So now let's take a look at something else. Remove. I think that's it for data types. Yeah, data types and their surface level methods. Like I said in the other class, these things you don't need to cram them. The more you practice, the more you understand, and the more you understand, the more you know when to use each of these inbuilt methods then. So yeah, let's move over to conditional statements. Now, what are conditional statements? Conditional statements are basically, hmm, 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 how best to describe it? Okay, okay. Conditional statements are basically sets of rules your program has to follow in order to achieve something or stop a process. You're still basically the same thing. Because if you're stopping the process, you're actually achieving that aim of stopping the progress. So let's get down into it. So basically, you give your program a set of conditions and be like, if this happens, do this. If it doesn't happen, do that. It's straightforward and it's easy. So let's take a look at the first type here. And the first one is your classic if else statement here. So let's give these conditional statements. Now, and how is it structured, your if else statement? It goes like this. If you give it a condition, now that condition must always return a boolean. must always return a boolean. Your condition must always return a boolean. Now, if that condition is true, it does this block of code. Else, it does this other block of code. Let me put here condition which must always be a bool. Now let's see it in practice here. So now if we go if, let's say my name, or rather my name double double. Oh, okay. So I think I skipped over something. I will go back to it. It's not all that major. So yeah, there's one thing that you guys should be aware of, and that is your notation signs over here. So now we have our first one, which is equal to sign. Now what the equal to sign does is assign a value to a variable. That's what it does. Now you have your double equal to sign. It checks if two values are equal. Now you have your exclamation and your equal to sign, which says checks if they are not equal. First one, a single one assigns a value to a variable. The second one, which is double equal to, checks if two values are equal. Now this other one, exclamation and the equal to, checks if they are not equal. With that being said, we can now enter our condition side. Now this side returns a bool. This returns a bool, a boolean too. Both returns a boolean. This only assigns. This two returns a boolean. Now we can now check, oh, my name, is it equal to Bongo? If it is, then print yes, I am Bongo. And this is the second part, which is the else. Print I am not the intended person. Let me comment this one out and hit run. You can see now my name, which is this variable here, holds Opongo. So Opongo equals, is this name here equal to this other name here? And it's returned, yes, I am Opongo. Now remember, this thing is also case sensitive. When you're comparing strings, it is case sensitive. So if I'm to put small letter O here and run it, you will see that it returns, I am not the intended person. So be mindful of that. Now, what is the name of this? Aha. We've also entered into the and or section. This is how you declare or. This is how you declare and in Boolean in that. So let's call these notation stem, notation signs. Now the thing is, with conditional statements, it can be on several levels. Not just if my name is Opongo, then do this. It can now be, oh, if my name is Opongo and other name is David. Now, the thing is, when you're using this operation over here, now this operation combines two conditions. You have your condition 1 and you have your condition 2. If you have multiple conditions, you can use this notation to try to bring everything together. Now, the AND notation states that the two or more conditions must be true for the whole statement to be true, to be considered true. If any of them, for any reason, is false, then the whole statement becomes false. Or, on the other hand, only waits for one condition to be true for all the statements to be true. It just waits for just one condition to be true. Then all the conditions become true. The total becomes true. In the same breath, for your all the conditions must be false for the total result to be false. Now, let's go with our and first. Yes, I am him. Let's go with it here. Let's run this and see. Now you can see that it entered this section of our code here, which is the part that says, yes, the result is true. In fact, I want to do something over here so that you can see what is happening. I'm going to put my condition inside here and print it out so that you can see the result of the boolean. Now once I run it over here, you can see that the boolean, the return here is true because my name is the same thing as Opongo and other name is the same thing as David. That's why it is entering inside here. But immediately I switch here to a small letter and run it, you can see that it returns false and you can see that it returns I am not the intended person. Even though other name is the same thing as David, but because this singular guy here does not satisfy this condition, that is why the whole statement here becomes false. Now let's duplicate this and switch to all. Now let's run the same thing again. Now you can see that, let me change it to big capital letter rather. You can see that, yeah, of course, my name is the same thing as Opongo and other name same thing as David. So everything return true. Now, if I'm to change here, let me just remove a letter here, remove a letter here. Now, this condition is not satisfied. Here becomes false, but this other side still remains true. But if we run it, you can still see that the totality returns as true. So or only requires one of the conditions to be true for the whole condition to be true. Questions? Yeah, I'm going to give you guys 5 minutes to take a look at this thing, then I'll come back for the questions. Okay, I am back. Okay, so questions. Questions, people, questions. Okay. Seems there's no question, so I'm just going to move on.
And then the or in it. Can you give an example of the and the or in a sentence?
Why were you hesitant why were you hesitant to ask the question? I was asking question, you kept quiet. The moment I want to move on, you are now bringing a question. Are you shy? In a way, you are shy. You said you should mix the and the or.
Yes, sir.
Okay, it's quite simple and straightforward. And this is how you can do it. Now, there is one thing that you should be aware of, and that is trying to have a mental breakdown of each individual condition, what their result is supposed to be. Example now, I have over here, this is my list of conditions, Abby. Now, in this my list of conditions now, I know that these two conditions over here will give me a false, Abby. This other condition over here will give me a true, Abby. Now, looking at these two like this from this perspective, we already know that our result will be true, Abby. Now, if I now make it more complex and add something like is Boolean equals to false or no value is not null. Now it suddenly becomes more complex. Abi? Now this whole thing now we can now try to represent it one by one individually. It's either you can do it like this, let's say, and this one here, this value in itself is true, so true is not this, so this will return false for us, or that is not null. Now is null not null, so yeah, this is false. So this is what it will look like here. You take this first section over here. Remember, try to, when it is this long like this, you try to take the first part, resolve it, take any of the connectors, then take the next one over here. Then after you have done that, you can now combine these two together to get a result. So we already know that false or true will give us something like this. True, Abi, which now leads us to this other section here, which is false or false, which will return false, Abi. Now it is being simplified. And of course, we know that true and false will always give us what? What will it give us? What will be the result?
And false.
False. So this will now be false. You can see how this whole thing here has been broken down step by step. Because in order for you to write conditional statements in a clean, clear manner, you yourself, you already have an expectation of what is supposed to happen and what each of your condition is supposed to give you. Now let's run this over here and see. Of course, I am not the intended person because that's what's to return false here. We can also do it like this. If you want it to be clean, you can also break it down in twos. You can put it 2. You can put it like this here. You see how I grouped these two together with the brackets, and you can also put these two together here in the bracket. So you can see now that this one, whatever results that you get from here and whatever results that you get from here, this one will now be the deciding factor. So it makes it easier and cleaner. And of course, you can add another conditional statement here, or you can add whatever it is, true or whatever it is here. Of course, it's true equals to false. Yeah, let's just put that on my side. So yeah, that is how you can combine them. It can get a bit tricky when you're combining them. So if you know that you have something like this that can belong, I would advise you to break it down into different levels. And what do I mean by that? Now look at this same code over here. We can rewrite it like this. If, remember, we are trying to determine if I am this person, Abi, if I am Opongu David, Abi. Now let's still take this whole thing over here. Okay. Now we can go for this first set of my name is Opongo, and we can delete this other part here. Don't worry, I'm coming to it. Now, if it is Opongo, we can now also do a check if other name is David. So you can see we can do nested if else statements. And we can now do print. Yes, I am here. And let's comment these ones out so that we won't be confused. And let's run this and see. You can see now it entered inside here because it satisfied this condition and it also satisfied this condition. Then I can just now put the else over here and do print. Nope, I am not. Then you can put else print straight to no. And you can hit run here. You can see I am him. Now if I change here, change my condition, you can do straight to no because it failed at this first point here.
Okay.
Yeah, so you can also have nested if else statements. Now there is one thing again that you should be aware of in if else statements. A single if else is a block of code. For example, now this if here and this else here, this if else here, they are a single unit. Now, if I come back again and do another if, this is a separate unit. Whatever is happening inside here is not going to jump inside here. this is a separate block. The same way that this one inside here is a separate block from this outside one here. And like I said, at this initial point, it will be confusing. So you just have to practice, practice, practice. Because no matter how I want to explain it to you, if you won't fully get it until you practice it. And of course, with the practicing comes lots of mistakes there, which is normal. Which is normal. Okay. And I think that should do it. Now there are other conditional statements.
Sorry, I want to get a question. This particular last example, I was expecting two steps of prints at least, but it's giving one step of print. For instance, the first one you ran, it said yes, I am in. The print it used was for the nested one. So when you now changed it, why didn't you use the nested print that it came out to say straight to no? Why didn't you use no, I am not?
Because look at my first condition here. It did not satisfy my first condition. That's why it jumped to this other one here. Now, see, if I'm to put it like this and I'm to put a condition that it doesn't satisfy, if I'm to run it here, you'll see that it goes to no, I am not. Because it satisfied this first condition here, which made it enter into this block here. And when it entered into this first if here, it now came into this one and went to check again, is this equal to this? Since it wasn't equal, it came to this else here. It did not jump to this one. It won't jump to this one here. It won't. It will remain here. That's why I'm saying that once you enter a block of if else, everything stays within that one. It doesn't jump out to another one.
Okay, for a situation like that first instance where the outside one is correct, but the inside one is not correct, why is it not also answering for the inside one that is not correct at least?
As in now.
If the inside one, how will I say it now?
Okay, you know what will happen? I will do some labeling here.
Why you know I am not answering?
Let me do this as, don't worry, let me do some labeling first. Let me do this to second. And let me make this third. And let me make this as the fourth. So yeah, ask your question using these numbers here.
Okay, what I'm trying to derive out two if else statements there, but it's giving only one response. So a situation whereby one of them is correct, like the let me say the inside one is correct and the outside,
David,
that's the first one.
David, there's
The
a
first
reason.
one is wrong.
David, wait first. There's a reason I just labeled it. Please use the label so
Okay,
that I'll
okay,
be able to follow what you are saying.
okay. So let's say the first one is not correct. The variable or the equal to sign is not correct for it, and then the second one is correct. At least if it will go straight to the print of that's the last print and say straight to no. The one that was correct, which is the second one, it is not making any statement regarding it, at least.
See,
I want to understand why.
once your condition is not met, it ignores the whole of this block here. It does not do anything inside here. It just goes to the next block. So if it only enters this section here, if this first one is correct. Okay. I want to ask you this question now. David, can you hear me?
Yes.
Okay. Let's say you have the idea to go and buy a shoe at ShopRite. Now, once you enter into the mall, if you see a shop that says eyeglasses, will you enter?
No.
Why not?
Maybe because that's not what I needed.
Exactly. So it's the same thing here. You're checking here. Oh, is this place selling shoe? Yes, it is selling shoe. Then you enter inside. Does this thing have size 45 for me? Yes, it has size 45. Then you enter inside. Now, in the same way, you come here. Oh, is this place selling shoe? Oh, no, it's not selling shoe. You leave it entirely. You do not enter inside where they are selling eyeglass to start asking further questions. Basically, what if else is about is that if a condition is true, then you can enter inside to do further computation. If it is not true, you skip that entire place. Same way that if you're going to buy shoe and you see a shop that is selling eyeglass, you skip that place. You don't enter inside the eyeglass selling shop and start asking them if they have size 45. Because already you already know that it has failed the condition, which is you sell shoe. Then if you go to somebody that sells shoes now, that's when you now ask them, oh, do you have color red? Do you have color black? What is the size of shoe that you have? That's when you now go further. So it's the same thing. It's the same principle. If the condition is met, you do further investigation.
Okay.
If it is not met, you go straight to the next condition over here. Is that
Okay.
clear?
Yeah. Yes.
Okay. Now to take our if else further, let's still take the same example over here. There is something called else if. Now, this happens if you have multiple conditions to check. Now, you can see I have a condition here. If my name is Okpongo, then it returns I am Okpongo. The next steps now, else if my name is David, then return I am David. But if it doesn't satisfy any of these conditions, then this is the last one here. So basically, your if else condition statement is that there are always conditions and there's always the last result that if none of the above conditions are met, that is when you can now run this one. Now let's hit run. Let's see, it returns I am Bongo. Now if I'm to tweak here a bit and hit it, it comes down to the I am David part. comes down to the I am David part because this did not satisfy the condition, but this satisfied the condition that you specified. That is why it ran this block of code. And of course, you can have as many if else statements that you like. It doesn't matter, you can have plenty if else statements. But it's not optimal for you to have this like this. That's beginner level coding. But you get the idea now of having multiple else if. So yeah, and each of those else if they represent a particular condition and it moves from the top to bottom, top to bottom, top to bottom. So now it starts here. If this fails, it moves here. If this fails, it moves here. If this fails, it moves here. If this one fails, it moves here. And if this fails, this is the last result. It gets to this point. So let's watch it happen. Let's put D, let's put DA, let's put DAV, let's put DVI, and now let's hit run. It got to the I am Opongo part, Abi. Now let me modify this Opongo part and you can see I am no one because none of our conditions here was met. But now if I put David over here and run, it's going to stop at this I am Dave section because it is only this guy that satisfied the condition before getting to this else statement section. So yeah, questions?
Not from me.
Lala?
None from me, sir.
Okay, in the absence of any, I think we're done for the day. So catch you guys